Hi, this is Grayson Huang, and we're going to present our project from this semester. First, I'm going to start with the data and the initial analysis. The data set we used is the current population survey taken from the gender pay gap data set on Kaggle. The data includes demographic information about individuals from 1981 to 2013. We did some data cleaning and ended up with about 300,000 rows and 31 columns, and we shrunk the time frame to 1990 to 2013. Our response variables are income and whether or not someone is making above the median income from 2020. And all of this is adjusted to 2010 inflation dollars to make comparisons across years feasible. We plotted a histogram of our response variable income and found that it's right skewed due to uncapped wages, and the majority of the income falls below 100K. We also wanted to explore how the gender wage gap we wanted to explore more about the gender wage gap, and this plot shows the difference between income by gender across all industries. And we did some additional exploration to visualize how data from different years would bias our results, and it's clear there's a wage gap across all years in the data set. However, it appears to be narrowing in recent years. Next, we wanted to look into correlations, and we found that the number of hours worked per week and whether or not someone has an advanced degree has the strongest correlation with income, and whether or not someone has less than or equal to a high school education and whether or not they're female, that's the most negatively correlated with income. And lastly, we wanted to check whether the difference between genders is significant, the income difference that we're seeing, and we used a permutation test and found that yes, it is clear that men make more than women, and ultimately, from this analysis, we can't conclude anything causally from that because we have not controlled for any confounding effects.
Now I'm going to talk about our regression analysis. For our continuous outcome, we fitted an OLS model with all the covariates, and we found that some of the variables with the strongest positive effect on annual income are the number of hours worked per week and whether someone has an advanced degree or not. And some of the variables with the strongest negative effect on annual incomes are whether someone's education level is less than or equal to high school and whether they're female. Similarly, with logistic regressions, we arrive at similar results. One thing of note is that the logistic model seems to place more emphasis on certain variables, like whether someone's working full-time or whether someone's the head of a family over the linear model. For our prediction model, we experimented with a variety of methods, and we found that for our continuous outcome, using lasso for feature selection on all features in the two-way interactions had the lowest MSE. And for our binary outcome, using rich regression with all features and the two-way interactions had the lowest 0-1 loss. To benchmark our model on the accuracy of the test set, we are comparing them with the baseline methods of just predicting the mean for our continuous outcome and just predicting the most common class for our binary outcome. And the results are that both of our models perform significantly better than the baseline method. In conclusion, once we controlled for all the covariates, if ignorability holds, we saw a decrease in salary of 5,200 corresponding to gender, which would represent biased hiring practices, but we cannot assume ignorability because there are idiosyncrasies not accounted for by the covariates. For example, we would like to have data on the opportunities afforded to a person along their upbringing. These are our next steps. The two that we would like to highlight are that we can explore splitting income into brackets and predicting whether a person will fall into a particular bracket to improve accuracy. And if time and resources permitted, we would like to explore more transformations of the features and see how they would improve model performance. That concludes our presentation. Thank you for listening.